Hey everybody. Today I'm hoping is a fairly straightforward one. You can see the title up at the top. What we're going to do is we're going to go through and we're going to build the equation of our parabolas. We're going to create equations for them. This is the sort of thing that we've done at times throughout the unit, but today I want it to be our focus. So what we're going to have is either a picture given, we'll see the picture of a graph, or we'll be given some properties of that graph, and we almost want to go backwards now. Could you build the equation of the function with those properties? So I don't think today is going to be a difficult one for us. We're going to go through pretty quickly a number of examples. I'm hoping by the end you'll feel really confident to tackle them on your own. So you can see the first problem on the screen right now. I have given you a graph of a parabola, and I would like you to go through and build the equation for it. We may even be at the point where the very first problem for today, you're trying it on your own. So if you feel confident with that, pause the video and give it a shot. Otherwise, you're coming along with me. So we take a peek, and you will notice that to build the equation of a parabola, it didn't say anything in the instruction about what form that needs to take. So it didn't say determine the equation of the parabola in vertex form or in standard form or in a factored form. No. What that means then is you can build it in any form you like. So for us to kind of work our way through, I would argue we probably have two different forms we're going to kind of zero in on that we're likely going to work through either in a vertex form or our standard form. Now, when I put up that standard form, I hope we realize that all that is maybe the expanded version of a factored form. You know, we had that sort of situation when we dealt with a family of functions. So, really, we're looking at those two. If I had to take a peek at the problem I was given in the picture, I think that would lead me towards using my vertex form. Like I can see my vertex, it's labeled on the diagram. And so because of that, I could go ahead and I could plug that information right into that blue form right away. So if I was to go through and tackle this one right now, what I'm going to do is I'm going to sub in my vertex, which is at 0, -3. I know within my equation, my vertex kind of lies in the position of the H and the K. I see that my vertex was not shifted horizontally. So if you're thinking that, that's okay. But it was shifted down 3. There's me subbing in my vertex. I can clean all of that up to at least this. And it gets me to that point. Now, this should sound very familiar or look familiar to you because it's kind of along the lines of a family of functions. You'll notice you have your vertex in the correct spot. Really, what we've paid no attention to is the shape of the parabola. You know, how steep is it? How flat is it? And you can see that within our equation because I still have that A there. So my job now is to define the shape of that parabola within the equation to make sure that the equation represents the proper shape. And what I can do is take a look at that other point I have on my parabola. Now, if I don't have a point that's labeled, I'm going to go on the hunt and try to find where my parabola crosses through the exact intersection of grid lines. I can see by that labeled point a point that my parabola has to go through, therefore defining its shape. So what I can do then is I can sub in that point and now figure out what shape would make that happen. So my y is 1. When my x is -2, I can square that right away. That's going to give me this equation, which should be really easy for us to solve. Okay, I'm going to go through, just shrink that down a little bit. Now for me to solve, divide out my 4, and I got an a value of 1. Okay, as soon as I went through that process then, if I shrink it a little more, that now allows me to state the equation of my parabola. I'm not going to write the 1 in because we recognize that a coefficient of 1, we don't write it, that's bad form. And there is your equation for that parabola. There we go. I would call what you see on the screen right now a very standard solution to that problem. Like so standard, it's almost a case where you could do that every time. Now, I do want to maybe walk back and take a look at another method that we use to sketch that could help us right now. To do that, I'm just going to erase some of the stuff that I have labeled on the picture, and I want to zoom in on the picture a little bit. You'll notice that I actually have a couple points where I can see my parabola go through the exact intersection of grid lines. And if I was to look at it from a step method standpoint, that is, I know that my normal parabola, if I was to go through and move from my vertex, would go over 1, up 1, then over 1, up 3, then over 1, up 5, and so on and so on and so on. That if I look from my vertex to my points, well, I notice if I go over 1, I do go up 1. Now, that's not sufficient for me to go, oh, okay, that's my normal shape. I need a little bit more to that pattern. So when I go through and I say I'm over 1 again and I'm up 1, 2, 3, that's where I can now really confirm I have a normal shaped parabola, and therefore my a value is 1. If you want to use the step method to examine your shape, feel free, you always can. But I want to see that work labeled on your diagram. You're going to need some proof, some reasoning for the reader of your solution to understand where this a value of 1 came from. Make sure it just doesn't pop out of thin air. You don't want somebody to be reading your solution and asking, yeah, but why? It should be obvious within your solution. So now that I shrink that whole thing down, I would call that a pretty representative solution. Okay, if you were able to tackle that on your own, outstanding. If you work through that one with me, I think we're now at a point where we can start to go through and build equations. Okay, let's try another one. Okay, you can see problem B. I would like you to do the same. Go through and build the equation, but I think everybody should be trying this one on their own. Okay, pause the video now. Okay, we're back. So if I went to tackle this the exact same way as what we just did, which is what I would anticipate given our walkthrough on problem A, you could start from vertex form. I see my vertex, and I could sub in that vertex of -3, 5. So my parabola pretty quickly becomes that. You notice again, we have not defined the shape, but you also notice that you have 2 other points that are labeled. So pick either one of them to use. I feel like I would tend to go through and use the -1 just because the numbers are smaller, but it's not like it matters. So I am now going to sub in that other point. So when my y value is 0, my x value is -1. -1 plus 3 is 2. 2 squared is 4. Now I have this equation. I could solve for A. And I want to highlight a couple quick things. First off, you got a -a value. And I'm hoping that really helps you, because that's what we should get. Take a look at your parabola. It's opening down. That's confirmation that, hey, I'm probably on the right track. If we were to go back and use our step method, you'll notice this one becomes a little more difficult. If I zero in on my graph, you might go, hey, it looks like I'm exactly through those intersections of grid lines. But now, something doesn't gel. If I go over one, down one, then I go, hey, I've got a normal shape. So that means I should go over one and down 1, 2, 3, and you go, oh, wait a second. That's not where my parabola goes through. It has it labeled that it goes through there at the green. So now I went over 1 and down 4. Okay, that's not consistent with my movement. My step method is causing me a problem here. So we may have been asking ourselves, hey, why don't you just use step method all the time when we saw it in the last problem? And now you can maybe see why. If I sub in my other point, I can solve for my exact A value. I don't need to trust my eyes on the exact intersection of grid lines. Okay, the only thing to do to finish that thing off is now write your parabola with its A value and its proper vertex, and you are good. Nice. Okay, I want to tackle this one a different way because I like variety, but also I really don't want to pigeonhole you into there is one way you must always do. I want you to notice what I'm going to do is I'm going to tackle this problem backwards, but it's going to look different, but I'm going to tackle it backwards. The reason for that, if you look at the 2 points that you were given, those aren't just generic points. Those are special points. Those are your x-intercepts. And when I know my x-intercepts, I know factors. So rather than using vertex form, what I might do is I might use a factored form. That is, I have to have some shape, but if I zero in on my first x-intercept, if I have an x-intercept of -5, then I know that it must have come from a factor of x plus 5. There's some of that family of functions discussion that we had earlier. Same thing, if I have an x-intercept at -1, then I know it must have come from a factor of x plus 1. I can build that because if you take a look at my purple right now, if I expanded those brackets, I get a quadratic. My highest degree, my highest power on my x is squared is 2, which means there is the proper shape, type of function. I just don't have the correct steepness. That's why you see that A out in front. So what I could do is I could use my x-intercepts to build my function. And now I could choose to use my vertex as my point that my parabola has to pass through. Okay, let me work my way through that one. So what I can do now is I can sub in that vertex and treat it like a generic point. So when my y equals 5, my a has to equal -3. So when I sub -3 into the first bracket, that first factor, it's going to simplify to 2, and my next factor to -2. So my equation then would solve, and you can see that we will solve for the same shape. Now, if I work my way through by using factors, then my equation is going to look different in the end. I'm going to now have a shape of -5/4 for my factors. And there we go. You can see my vertical stretch factor that gives me the proper slope. I would take either one of those equations, the blue or the purple. There's nothing in the problem that says it has to take one form versus the other. You can pick. If there was something in the problem that said, like, for instance, it had to be in vertex form, then obviously I'm given the blue. If the problem had said standard form, then I think I'm doing the purple. And then all I'm going to do is I'm going to expand my brackets and collect like terms, put it in standard form, and I'm good. Okay, 2 different ways to go through and build the equation. I'm hoping that we are broadening the things that we have at our disposal. Okay, let's try another one. Okay, you take a look. I've given you the picture of the function again. I want you to try this one on your own. Everybody is. Let's pause the video now. Okay, we're back. So, same sort of thing as before. I'm going to go ahead and I'm going to put on 2 different solutions for it. This might just be a little weird because you might look at it and say, like, but it's the same method. It's not really. Okay, the first way, since I see my vertex, then maybe I'm going to use vertex form. And so I know my generic vertex form. And I can go ahead and I can sub in my vertex at 2, 0. So that means with my vertex put in, that's what I get, but I'm clearly not going to write a plus 0 on the end. There we go. Now that I've done that, I can see the point 4, 4 through my parabola. So I can sub in that point that I passed through. 4 minus 2 is 2. 2 squared is 4. And I can divide out my 4 and get to my value of 1. There I go. Not too bad. Finish it off. And there is my equation. Okay, my alternate way is going to look very similar. This is not something that I would expect you to know. Not at all. We have not discussed it. But there is something that's called multiplicity of roots. That is, this is going to be a topic that you discuss in future math courses. That when you see your x-intercept at 2, you may be tempted to say, hey, but why don't I just use my factors? I can see that I would have one factor being x minus 2 because I have one x-intercept at 2. Like this is what we did in the last problem. If I have an x-intercept at 2, I know it must have come from a factor of x minus 2. But then you start to look at it and you say, yeah, but like, what's the other factor? And I'm going to tell you, we already know it. That when we have our curve approach, and I want you to take a look at our graph, approach the x-axis, touch it, but not cross. What that tells us is that factor has to show up multiple times. And since this is a parabola, the most times it could show up would be twice. Multiplicity of roots would actually say that it has to show up an even number of times, and since it's a parabola, it has to show up twice. That I could come in on that as my first line using factored form. You'll notice I said it's going to look like I'm using the same method, but I really didn't. Okay, you don't need me to go through that purple and sub in my other point again. We're totally fine. You are good. Okay, I am hoping that that gives you something to be able to work through. When given a picture, can you go through and build the equation? Okay, all we're going to do for the rest of the day is a few more examples, but let's get rid of the picture. You now have that under your belt. I think we should be fine moving forward. So take a look at problem 2. The same instruction. Determine the equation for each parabola. But now I didn't give you the graph. I've given you properties. I think you should be good for this one. I want you to try it on your own. Okay, pause the video now. Okay, we're back. So I am hoping that with this picture omitted, it caused no change for you. That it's going to feel like we're working a little more in the abstract just because you can't see it, but I'm hoping that we are really automatic. If I gave you that vertex, then maybe your first line is to just go ahead and sub it in right away. Now that you have that vertex, that vertex form, sub in your point. So what would that solution look like with proper form? I would expect you to write that you are subbing in your vertex so that your reader understands where this line comes from. Now, sub in the point. It's a generic point now. Your y value is 8. When your x value... Wow, I seem to be getting a lot of 2s inside my bracket. That is a complete fluke. I would argue on my end, that's a bad selection of examples. But there's another case of 3 minus 1 is 2, 2 squared is 4. Trust me, that is all just a fluke. Bad patterning on my part. Now I can go ahead and solve. I get another instance where my a value is 1. I get my normal parabola again. Go ahead, write out your equation, and we are good. Okay, I would expect a lot of you to have that solution. Even though we don't have the picture, it wasn't needed. We should be comfortable with the process. Okay, make sure you have all those little communication statements. I would expect to see everything you see on the screen right now in your solution. Okay, let's try another one. Okay, you see problem B. Same thing as normal. Let's go ahead and give it a shot on our own. Pause the video now. Okay, we're back. So, same thing. I gave you vertex. We should be getting really, really good at this. So, you are going to sub in your vertex. And I gave you a y-intercept. Now, you might be looking at that and going like, hey, but like my y-intercept. Okay, my y is 1, but what's my x? Please just remember that when I give you a y-intercept, that means x is 0. So what I'm actually subbing in then is the point 0, 1. Okay, we end up getting to this. Oh my goodness, it happened again. This is horrible. I swear I'm building up this instinct in you that, hey, you just always end up with a 4 times your A. No, it's horrible examples. So now I can get rid of my 9, divide out my 4, and there we go. So we get into that instance. You can now go ahead, put in your A value, and you have your parabola. Okay, let's say that this is you on an evaluation. You just finished that problem. You look on the clock, you say, hey, I've got some time to go through and check some stuff over. How would I check this solution? This would be what I would do. I would put on a quick set of axes on the back of a page or somewhere off in the corner that I'm going to box in and X out just to note it's not part of my solution. If I go and put my vertex at -2, 9, and then I have a y-intercept of 1. Remember, this is my vertex. So the only way that I can go from my vertex to my y-intercept is to open down. You will notice I get a little confirmation. Yep, I should have got a negative A value. I'm hoping that you were quite comfortable to deal with that. Okay, the second part that you can do when you go through and you check. Let me just get that negative back in there. You could now use your step method. Since I have an A value of 2, that means that I am no longer moving to the right one down 1. I'm moving down another 1. I'm doubling it. So that means I would have to go down 2. Then I would be to the right one, and rather than down 3, I'm down 6. I have to stretch that parabola and make it steeper. So I could check my shape now on my sketch. Right 1 gets me to an x value of -1. If I go down 2, that gets me to 7. I get it. My notes make it look like I went down 7. I'm not. Remember, I'm using this as a check. Because now when I go over another 1, that gets me to 0, which matches up with my y-intercept. So when I have to go down 6 because of my a value, I get confirmation, yep, that was my y-intercept at 1. I know I'm correct now. I know I am. So that's what you can do if you have a little bit of extra time on the end. Now, if this is on your solution page, just go ahead, box it in. Make sure that I'm not marking that as a part of your solution. Okay, there we go. Nice. Okay, let's try one more. Now, okay, I want you to give problem C a go. Try it on your own. Pause it now. Okay, we're back. So you'll notice I gave you some different properties this time. I gave you the axis of symmetry was x equals -4. I gave you a maximum value of 5, and I told you a point it was passing through. So you may look at that and say, oh, I'm not sure how to go through this. Like, you've always given me the vertex in the past, or I had a way to figure out the vertex, and I don't now. And I'm going to say to you, sure, I gave you the vertex. I just wasn't explicit with it. Remember, on our picture, your axis of symmetry being over here at x equals -4 tells you that your vertex has an x-coordinate of -4. So in a way, I gave you part of your vertex. Just wasn't explicit. You'll also notice that I told you that you have a maximum value of 5. So within that statement, I told you two things. It's a maximum, so I know my parabola opens down, and the value of that is 5. So up here, my parabola will never go above 5. Well, then that means I actually told you the y-coordinate of my vertex. So I wasn't as explicit as I was in the past. I didn't tell you the vertex is this, but I gave you a way to get the vertex. Okay, we should be pretty automatic to finish this thing off. The rest of this is just confirmation. If I went through and I subbed in my vertex of -4, 5, then I need my generic A value. There is my vertex form. I am now subbing in my point that I know that parabola goes through. Oh my goodness. A times -2 plus 4 is 2. 2 squared is 4. I swear this was not intentional. Bring over that 5, divide out and simplify. There is your A value of -1/2. So what I can do then, go ahead, state my parabola. It has a value for A. It's been stretched vertically by a factor of 1/2, so it's a flatter parabola. Opening down, there's my confirmation on my max. Put in my vertex, and I am good. There we go. Hopefully not too bad. So today, I gave you a picture, build the equation. Or I gave you properties, build the equation. I'm hoping you can see the process that we went through, and I'm hoping that you're comfortable with it. Like normal, jump in, get some practice, okay? Make this as automatic as possible. Best of luck.